Let's head out to the Marshall Space Flight Center in Huntsville, Alabama, where Lori Meggs is standing by live. Lori, we are learning about oceans from space. What can you tell us about this?
That's right, Amico. It's called HICO, or Hyperspectral Imager, for the coastal oceans. And this is a special camera that allows scientists to study the coastal regions and environmentally characterize those coastal regions, the land and the water. This camera separates light into hundreds of wavelength channels that provides information on the composition of the land and water along the coast. I recently spoke with one of the investigators from the Naval Research Laboratory at Stennis Space Center to find out more.
It's a hyperspectral high-resolution sensor that measures the reflectance of light out of the water. So it extends a long time series of measurements that NASA and European countries have made for several decades, but it has also several unique capabilities and applications specific for the scientific and naval communities.
What are some of those unique capabilities?
Well, it's the only sensor in space that measures the light spectrum hyperspectrally. So as opposed to some of the standard ocean color sensors that have maybe 8 bands, HICO has 128 very narrow resolution bands that help us distinguish and unravel the optical components in the water column. And those optical properties influence light penetration, so they're important for primary production measurements, phytoplankton distributions, as well as topics of interest to the Navy, anything that's impacted by the penetration of light.
For those who don't know, what does hyperspectral mean?
Okay, we're looking at visible wavelengths from about 400 to 900 nanometers at discrete channels of about 5.7 nanometers. So every 5.7 nanometers over that spectral range, we've got a separate signal. And different phytoplankton pigments and properties in the water absorb light differently. So as the light's transmitted from the sun, some of it reflects off the surface of the water, some of it penetrates. And when it's in the water, the dissolved and particulate material alters that spectral composition. And when it's reflected back to the sensor, we can look at that difference and try and understand what was in the water that caused that.
So why is this data important to have?
Well, the phytoplankton are the base of the food chain. They're the main source of primary production in the ocean, so it's important to map their distributions and understand what controls their biomass and growth. And by measuring the light coming out of the water, we can map these distributions on synoptic scales at very high temporal and spatial resolutions globally.
How does it all work?
Well, HICO measures the radiance at the top of the atmosphere out from the International Space Station. So in that signal is the water leaving radiance, which is what we're interested in, as well as the atmospheric radiance, which is our noise. So after we perform an atmospheric correction, we're left with the water leaving radiance. And from that spectral signature, we can try and unravel the dissolved and particulate material in the water column.
So when did you launch? How long have you been there?
It was launched and installed on the space station on the 24th of September in 2009. So it's been up there almost 4 years. We've collected over 8,100 scenes to date, and it's been a great demonstration of the potential for hyperspectral imagery, the optical properties and the environmental properties of interest to the Navy as well as the scientific community.
Any results so far that you've shared and maybe some spin-offs?
Sure, yeah. We've, as I said, we've collected a lot of imagery globally, so we can look at the high-resolution coastal processes anywhere in the globe. We can select our own targets. We've applied some new optimization algorithms where we can estimate water depth, water optical properties, and bottom reflectance simultaneously. And we've partnered with the EPA to monitor coastal areas of the United States, and we're trying to bring that to a broader audience so that we can present it like we do weather, where we have an application where we can look at ocean conditions easily for the general public.
What's next for HICO?
Well, I think we have at least another year of operations on the space station. We're hoping to be right next to a LiDAR sensor that's going to go up next year, so by combining the active and the passive signals, we'll get even more information from the ocean.
And for more information on this and other investigations, go to nasa.gov/station.